Hi children, today we are going to be discuss that is ninth class, third chapter, Elements of Geometry. In my previous video, I have explained that introduction about the elements of geometry, and here I will explain you in this video in the elements of geometry exercise number 3.1. We have only one exercise in this chapter, so let us complete that exercise. Already in my introduction about this chapter, I explained some important points which is help us to complete this exercise completely. How many dimensions a solid has? Already I told you a solid figures having 3 dimensions. How many dimensions? 3 dimensions. A solid figures having 3 dimensions. What are that? Can you tell? Yes, length, breadth, and height. A solid can have a 3 dimensions, that is length, breadth, and height. And see the second one. How many books are there in Euclid's Elements? There are 13 books. Okay, 13 books which are written by Euclid. The Euclid Elements. Write the number of faces a cube and cuboid. So the number of faces here, number of faces equal to 6 and 6. A cube having 6 faces and a cuboid also will have 6 faces only. That means a flat surface areas of cube and cuboids. Flat surface areas of cube and cuboids, nothing but the number of faces are 6 and 6. Then fourth one, we have to answer this all. What is the sum of interior angles of a triangle? The sum of interior angles of a triangle. The sum of interior angles of a triangle is equal to 180 degrees. Very simple questions. Basic geometrical introduction. And write 3 undefined terms of geometry according to the Euclid, that is a plane and point and line. These are the 3 undefined terms according to the Euclid. And this is the first bit we have completed. And we have to write the second bit, true or false. Let me read the statement. You see that what is the true and what is false statement. Only one line can pass through a given point. It's a false statement. Only one line can be passed through a given point. Suppose I have given one point. How many lines will pass through this given point? We can pass through 1, 2, 3, 4, 5, 6, 7, 8, infinite. Infinite number of lines will pass through the one given point from the one point. Okay. Suppose they have given 2 points. Only one straight line will pass through the given these 2 distinct points. This is called Euclid postulate. Yes. The second one. All right angles are equal. Yes, true. All right angles are equal according to the Euclid postulate. Yes. Circle with the same radii are equal. Yes, this is also true. Suppose a circle with a 2 centimeter, it is equal to the another circle with a 2 centimeter. These two are equal circles when they have same radius. If radius are equal, hence the circles are equal. Then here they have given a finite line can be extended its both sides infinitely. It's get a straight line. Yes, a finite line will be extended. Suppose it is a finite line. Suppose if it is extended on the both the sides to make a straight line. Yes, it is also a true statement. This also we have learned in the Euclid postulates only. Then we have a fifth one, that is E1. From the figure here Here A, here it is B, and here there is a C. This is a figure actually. From this figure, AB is greater than AC. Yes, AB is greater than AC. Yes, whole is greater than the part. The whole is greater than part. According to the Euclid axiom, the whole is greater than the part. This whole, complete whole, that is AB line is greater than the AC line. Yes. So this is the first bit and second bit. First bits are question and answers actually. They have given a simple what is solid figure, how many books in the Euclid elements, and how many dimensions of a solid figure, and cube and cuboid, how many faces it has, and defined terms according to the Euclid. These are the first bit of questions actually, and the sum of three interior angles of a triangles. Very simple questions in the first bit, and second bit we have seen the true or false. Now the third question. Third question here. Yes. In the figure given below, show that. Okay, I will also draw the figure here. First of all, show that this we need to prove it. AH equal to AB plus BC plus CD. So this is the figure here. A to G, H, A, B, C, D, E, F, G, and H. Okay, he is given this. We have to prove this. AH is greater than AB plus BC plus CD. So we know that according to the Euclid, here whole is greater than part. Whole is greater than, okay, according to the Euclid postulates, here whole is greater than part. So in that way, I can say here AD, suppose AD is less than AH. Suppose complete that AH is the greater part, this is the whole part. In that, this whole part is greater than, this whole part is greater than AD, the part. This AD, however, a small one comparing to the AH. This is what I have written. So keep this as a statement. Like, so now we go for, suppose AD equal to, what is AD equal to? Let us see. AD equal to what? AD equal to the sum of AB plus BC plus CD. AD is nothing but till AD only you observe. Here AD is equal to AB plus BC plus CD. That I have written. So this AD equal to AB plus BC plus CD will substitute in the equation number 1 here. In this one, AH is greater than. AD equal to what actually? This AB plus BC plus C and spool. So this problem is given here. We understand that the whole is greater than the part. We have to understand the whole always greater than the part in that. Yes. Suppose this is a complete board. It is greater than the some part in this. Simple. So the whole is greater than the part. Next. Here question number 4. If a point Q is lies between 2 points P and R, if a point Q lies between 2 points P and R, okay, such that here PQ is equal to QR, then prove that this is given that actually GT given that, then we have to RTP, we have to prove that RTP required to prove that RTP required to prove that PQ is equal to 1 by 2 PR. This is what we have to do. Let us prove that. Proof. This we need to prove. This is given that if a point Q is lie between the P and R. Suppose let us take here P and R. Here Q is lying between these two, such that here we also given that here PQ is equal to QR. Here PQ is equal to QR. This having same length. That means Q is the midpoint. Q is a midpoint. Q is a midpoint of PR. That we need to understand. Okay, now we need to prove this. How can we prove? Okay, I know that here whole is greater than part. Again, whole is greater than part. This we know. So whole is greater than part now. So what is here whole? That is PR. Here PR is greater than sum of these parts. Or else without using these statements also we can do it that. Let me go for that. Here PQ plus QR is equal to PR. PQ plus QR is equal to what actually? PR. Yes or no? So, but we know that PQ is equal to QR. That means instead of QR, I'll put a PQ here. PQ, and this QR is equal length of PQ. So here also I'll write PQ, that equal to PR. So 1 PQ, that is 2 PQ is equal to PR. Here 2 is multiplying to PQ. So you transfer this that become a divides. So PQ is equal to 1 by 2 of PR. Hence prove. Hence we prove that. Here QR, this QR is equal to PQ. That means instead of QR, if you write PQ also, it will be same only. Because these two are same already given in the question. The same thing we have written here. Instead of QR, I have written a PQ. Sum of 2 PQs is 2 PQ. If you transfer this 2 to the other side, that will divide, hence we can show our required things. The next question, the fifth question is construction actually. In your 7th class already we have learned that how to construct the triangle. Here very simple construction they have given a equilateral triangle. Construct the equilateral triangle with the length of 5.2 centimeter. Simple. You take 5.2 centimeter as a base of this triangle, and suppose you have given a name of this base like AB. From the A again you take a compass and take the radius on the compass, that is 5.2 centimeter you take as the radius, and draw an arc from the point A and draw the another arc from point B, and the intersection point of this arcs you locate as a C and join this AB and BC. Hence it is called equilateral triangle with the length of 5.2 centimeter of each side. So this kind of construction of triangles you have done in your 7th class only. So I am not going to teach you here. I'll go for the 6th question. This 6th question also I have explained in the previous introduction about these elements of geometry. In my previous video I explained what is conjecture. What is conjecture and the statements which are neither proved nor disproved are called as a conjecture. The mathematicians, the invention of mathematicians will prove the outcomes will be always like a conjectures only. For example, every even number which is greater than 4, every even number which is greater than 4 can be written as sum of 2 primes. This is the example I have given, that is there in the textbook also. I have explained about the conjecture clearly in my previous video, that you need to see it. That video link I will keep in the description, you watch it. Then 7th question, we go for the 7th one now. Yes. Mark 2 points P and Q. Draw a line through the P and Q. Okay. Mark 2 points P and Q. P and Q. And what is it? Mark 2 points P and Q. Draw a line through the P and Q. Yes, I can draw a line through the P and Q. Yes, I can draw a line through the P and Q. Yes. Now, how many lines are parallel to the PQ? Can you draw? how many lines you can draw to the parallel to the PQ? Can you draw it? Yes, I can draw infinitely many lines which are parallel to the PQ here, upside and downside. Hence I can write infinitely many parallel lines. How many you can write? Infinitely many parallel lines I can draw. Okay, in this way I can show it. Here I mark P and Q and join P and Q with a line, and to this line I can draw the infinitely many parallel lines. Yes, that is what seventh one. And question number 8. In the adjacent figure, yes, in the adjacent figure, let me draw the figure first. Yes, in the adjacent figure, line L falls on the lines L and M. Line L is falls on the line L and M, such that the sum of the interior angles, the sum of this interior angles, angle 1 plus angle 2, the sum of interior angles is less than 180 degrees. That means angle 1 plus angle 2, it is less than 180 degrees. Yes, less than 180 degrees. Then what can you say about the lines L and M? What can you say about these lines? So L and M, if we produced or extend, if you produced or extend, if we extended these lines L and M, they meet each other, and at last we can say L is not parallel to M. L is not parallel to M. If you extend this, they meet each other in the future. Hence we can conclude that because the sum of these two angles is less than 180 degrees now, if you extend this side, these lines, definitely they intersect each other. According to the Euclid postulate number 5 will explain the same thing. Based on the same, he have given a problem here. Yes. The question number 9 now. Here you given a parallelogram. This is based on the Euclid axioms. Angle 1, 2, 3, 4. Given that in the adjacent figure angle 1 is equal to angle 3 and angle 2 is equal to angle 4 and angle 3 is equal to angle 4. Okay, write the relation between the angle 1 and 2 by Euclid postulates. Yes, the Euclid postulates what he said. The things which are equal to each other are equal. The things which are equal to the things which are equal to the same things are equal one another. See, angle 1 is equal to angle 3, angle 2 equal to angle 4, and here angle 3 equal to 4 is 3 equal to 4. So angle 1 is equal to angle 2 also we can say. So here what we get, angle 1 is equal to angle 2. So what can you say about the angle 1 and angle 2? They are also equal. That angle 1 equal to angle 2. So this is a Euclid. According to the Euclid, we can say that the things which are equal to the same things are equal to the one another. So here the last question of this exercise and this chapter also. In the adjacent figure, okay, the figure name A, B, C, ABC, here X, here Y. In the adjacent figure, given that BX is equal to, this BX is equal to 1 by 2 AB, half of the AB. 1 by 2 AB, this is half of the AB. BX is a half of the AB and BY is half of the BC. And we also given AB is equal to BC. AB and BC are equal in the sense here X and Y are called as the midpoints of AB and BC respectively. And we have to show that, required to prove that BX is equal to BY. BX is equal to BY. So how can we prove that? Here proof, see that as is given here, AB is equal to BC. That means suppose here given AB is equal to BC. This is what is given here. Let us take this condition. AB is equal to BC. This is given actually. From the given only we have taken. So half of the AB, I am doing half of this AB. I am doing half of the, let us divide BC. Divide by 2. Both the sides. You have to understand that Euclid axiom, the things are to each other, same things, they are equal to one another. In the Euclid axiom, we have studied that last Euclid axiom. The things which are half to same things are equal to one another. So half of the AB equal to what? Half of the AB equal to BX. Here half of the BC equal to what? That is BY. Hence BX equal to BY. That is what we need to prove now. Hence proved. Okay, here you need to write that the Euclid axiom, one more Euclid axiom. The things which are half of the same things are equal to one another. I hope you understood this exercise number 3.1. Practice this chapter. This is a well scoring chapter in the 9th class and very small chapter. So thank you for watching this video. Thank you.